All right, hi everyone. So today we're going to talk about negative exponents, so stuff that looks like this, x to the negative third, and we're going to talk about raising things to the power of 0. So we're going to review what those look like. We're going to go ahead and get started. So the first thing we're going to talk about is the 0 rule. So this is when you take something and you raise it to the power of 0. Anytime you do that, so if you have something like this, x to the power of 0, it is always going to equal 1, positive 1. And it works for every number except 0. It doesn't work for 0, so that's why this says non-zero. So anything to the power of 0 will always equal 1. It will not equal 1x or 0. Some people like to try to say that that's what it is. It's always just going to equal positive 1. And I'm going to show you very quickly why that works. So the reason why that is true, here's a very quick explanation of it. So we know that exponents, this is how they work. So 2 to the third power, we know that that's 2 times 2 times 2, which is 8. 2 to the second is 2 times 2, which is 4. 2 to the first would just be 2. And then 2 to the 0, so if I'm just following a pattern here, 3, 2, 1, 0. 2 to the 0, I'll show you why you're going to get a 1 for that. So if you look at these numbers over here, these are all being divided by 2. If you divide 8 by 2, you get 4. If you divide 4 by 2, you get 2. So if I continued that, if I divide 2 by 2, well, that's just going to equal 1. So that is why 2 to the 0 would equal 1. And that pattern works for any number that you would try to do that with. So this is one good explanation of why it works. There's lots of other good ones out there, but that's just kind of a quick one. All right, now we're going to get into some examples. So we're going to start with just some basic ones. 6.7 to the 0 power, well, that's just going to equal 1, positive 1. So the next one over here, this one's a little tricky. This negative, because it's not in parentheses, it actually is it's kind of like a coefficient of negative 1. So it's separate from this 534. So we would say that this part is definitely equal to positive 1, but we also have that negative on the outside. So we would actually say that this final answer is negative 1, not positive 1. And that's because the negative is not in parentheses. So in the next example, you'll see that it actually is in parentheses. So that means that this entire thing here, this negative 7 to the 0, that equals positive 1. So that turns into positive 1. We still have this x to the fourth, but 1 times x to the fourth is just x to the fourth. And then over here, we've got the 0 power is only on the x, so this part would equal 1. We still have that 4 in front of it, though, which means we need to multiply those. 4 times 1 is just 4. And then if I bring this down, so now I have 5x to the third, and I'm supposed to multiply that by 4. So if you go ahead and do that, that would just equal 20x to the third. All right, so that is the 0 rule. Now we're going to talk about negative exponents. So negative exponents, they actually don't have anything to do with negative numbers. They actually kind of represent fractions. So if you see a negative exponent, you need to rewrite it as a positive exponent by moving them to the opposite side of the fraction. So here's what the rule says. It says x to the negative a would equal 1 over x to the positive a. So we're just moving it to the other side of the fraction. So if it starts in the numerator, you have to put it in the denominator. If it starts in the denominator, so if we had something like this, 1 over x to the negative a, then you would have to move it to the top of the fraction. So this would just turn into x to the positive a, which would really be over 1, but we're not going to write that 1. So that's how it works. You basically just switch places. Wherever it's at, you have to move it. And I'm going to show you why that works. So it's very similar to the pattern I showed you for the 0 rule. We're just going to basically continue that pattern. So that pattern started with 2 to the third. So we said that that was equal to 8, and then 2 squared equals 4. 2 to the first equals 2. 2 to the 0, we learned that that equals 1. Now if I continue this pattern, I'm going to get down into negative exponents. And if I continued this dividing by 2 pattern, right? So I'm supposed to divide by 2 every time I go down here. So 1 divided by 2 Well, that's just 1/2. I'm going to leave it as a fraction so we can see the patterns here. If I divide this by 2, 1/2 divided by 2 is 1/4, and 1/4 divided by 2 is 1/8. So I'm going to zoom in on just these negatives so you can see those. So 2 to the negative 1 is 1/2, which is the same thing as 1 over 2 to the positive 1. 2 to the negative 2 is 1/4, and that's the same thing as 1 over 2 squared. And then 2 to the negative 3 is 1/8, which is the same thing as 1 over 2 to the positive 3. So you can see the relationship here. This negative exponent became a positive exponent, and it just got moved to the bottom of a fraction. So 1 over 2 to the first, this one became 1 over 2 to the second, this one became 1 over 2 to the third. So that's kind of how negative exponents work. It's basically just dividing by the same number every single time. So we're going to go ahead and do some examples here. We're going to start with examples that don't have variables. So let's go ahead and do this first one. 3 to the negative third. Well, that's got to get moved to the bottom of the fraction. Now remember, it doesn't look like a fraction right now, but it really is because there's a 1 on the bottom, right? So if I take this and I move it to the bottom, well, now this becomes 3 to the positive third on the bottom. On the top, I would just have a 1 left over because technically there is a 1, in front of that. So that would just be a 1 left over. Okay, so this is what it would turn into, but we do actually want to evaluate this 3 to the third. 3 to the third is 27. So we're going to write this as 1 over 27. All right, same thing for the next one. So we have negative 2 to the negative 4th power. So that entire base needs to get moved to the bottom. So negative 2 to the positive 4th power, I would have my 1 left over on the top. And then if you evaluate that, that would actually be 1 over 16. The next example, the negative exponent starts in the denominator. It starts in the bottom of the fraction, which means we need to move it to the top of the fraction. So that would turn into 1 times 4 to the positive third, which is just 64, because 4 to the third is 64. So that is our answer. And we wouldn't have anything left on the bottom. I mean, technically we have a 1 left on the bottom, right? But you don't have to write that it's just a 1. All right, and then this last example, this actually uses the 0 rule as well. This part equals positive 1, and then we would have over 2 to the negative 2, and we have to move this to the top of the fraction. So this entire thing would just turn into 2 to the positive 2, which is 2 squared, which equals 4. All right, so now let's do some examples that have variables. So on the first one, x to the negative 6, we're just going to put it on the bottom of the fraction. So that would be 1 over x to the positive 6. The second one, it's a little tricky. So we've got a coefficient in the front here. This negative exponent, it is only attached to that m, that variable m. It is not attached to the 3. The 3 technically does have an exponent. It's got an exponent of positive 1. So that means when we make our fraction, the only thing that we're moving to the bottom is this piece, the m, so that's going to be m squared. The 3 actually has to stay on the top because it does not have a negative exponent as a positive exponent. So we're going to leave that on the top of our fraction. So this is what our final answer would look like. In the next example, both of these are negative exponents, so they both have to get moved to the bottom. A squared, b cubed, and then on the top we would just have 1. All right, in this one we have one negative exponent and then we have a positive exponent. So when we make our fraction, the only one that gets moved is the negative. So that's going to go to the bottom and become a positive 2, and then the x to the 5th is just going to stay on the top. All right, in this example, let's see, we've got 2 to the 0. Well, we know that 2 to the 0 equals 1. And I really can just kind of get rid of this because it would be 1 times x squared, which is just x squared. So I don't really need this piece right here. It's just x squared left on the top. So this piece, gonna get moved up to the top since it's a negative exponent. So this would become x squared y squared, and the only thing left on the bottom would be a 1, which means we don't have to write it. So we're just going to leave it like this. All right, and over here we've got another 0, so this equals 1, which means I don't really need to write it. So I really only have 4 over y to the negative third, and then this negative exponent has to move to the top. So that's going to turn into 4 times y to the positive third. All right, we've got a few more examples left. So in this one here, we've got 3 different pieces here. We've got the -7, we've got the a, and we've got the b. And the only one that has a negative exponent is the a. So that's the only part that's going to get moved to the bottom. And then the -7 and the b, those have to stay on the top. So this is what our final answer would look like. In the next example, it's kind of similar. So we have a negative exponent here, so that's going to go to the bottom, m to the 4th. This we don't really need to write because it just equals 1, and it's not going to do anything if we leave it there. And then this piece would stay on the top, so we're going to have our 14 left on the top. The next one's very similar. So I have a 1 right here, which means I don't really need to write it because it just equals 1. And then I have a negative exponent, so that's going to go to the bottom, g to the 9th, and then the 12 is going to stay on the top. All right, for the next one, this is equal to 1, so we don't need to write it. And then both of these are negative exponents, which means they're going to both have to move. So they're kind of going to switch places. So when I rewrite my fraction, the b is going to go to the top, so b squared, and then the 3 is going to go to the bottom, 3 squared on the bottom. And we do actually need to evaluate that 3 squared. That equals 9. So we're going to simplify this to b squared over 9. All right, in this example, this is a 1. It just equals 1, so we don't need to write it. And then the only negative exponent that we have is this u to the -5. So we're going to move that to the bottom, which means on the top, we still have the t left over on the top. So it would be t over 2 to the 5th times u to the 5th. And then you can actually evaluate 2 to the 5th. 2 to the 5th is 32, so that would be t over 32u to the 5th. All right, and then the final example here, these are both negative exponents, which means they are going to both have to move places. So the x is going to go to the bottom and the y is going to go to the top. So this would turn into y to the 5th over x squared. All right, and that is it for this lesson. So if you have any questions, make sure you let me know. Bye.